Section 36 is entitled Complex Fractions. Suppose you had, say, 2 over 3 plus 4 over 7 divided by 5 take away 2/3. One way to solve this is you can add the numerators and you would get, oh my, in the top, in the numerator, you would get, I think, 26 over 21, and in the bottom, you would get 13/3. And then you would say, well, you keep the top number, you change division to multiplication, and you flip over 3 over 13, and 3 goes into both of these numbers 1 time and 7 times, and 13 goes into both of these numbers 2 times and 1 time. You can't reduce anymore. 2 times 1 is 2. 7 times 1 is 7. The problem is done. But that's way too hard. What you can do is, in the numerator, you have denominators like 3 and 7. And in the denominator, you have denominators. So what you want is the LCD. That is, you want the LCM of the 3, the 7, and the 3, which is the same, coincidentally, as the LCD of 3 and 7. The LCM of 3 and 7. What's the first common multiple they have in common? And it turns out the answer is 21. The LCM is 21. So rather than actually suffering through adding these two fractions on the top and subtracting the two fractions on the bottom, which is hard for some of you, I understand that. Instead of doing that, we're going to get rid of those denominators, the ones in the top and the ones in the bottom. So we're going to take the 2/3, the 4 over 7, the 5, and the 2/3. And we're going to multiply by 21. Now, a lot of students might get as far as what I did right here. And then they'll say that 21 times 2/3 is 42/3. Because 21 times 2 is 42. Absolutely correct. But you completely lost why we are multiplying by 21. Either you never had it, or you completely forgot why we're multiplying by 21. The reason we're multiplying by 21 is so we don't get answers like 42 over 3. You don't want a denominator. If we pick 21 because 3 goes into 21. 7 goes into 21. 3 goes into 21. There are no denominators anymore. That is, no denominators in the numerator, no denominators in the denominator. The numerator is simply 7 times 2, which is 14, no denominator, plus 4 times 3 is 12, no denominators. In the bottom, 21 times 5 is 105, minus 2 times 7, which is 14. There are no denominators. The top is 26, and the bottom is going to be 91. And it turns out that 13 goes into this number 2 times, and 13 goes into that number 7 times. And that's why you get 2 over 7. There it is. Okay, we didn't have to actually add any fractions. We didn't have to subtract any fractions. We just added integers. You have 3 over thirds, and in the bottom you have 5 thirds, and you take away 7 over x. So you need to look at 4, 3, 3, and x. 4, 3, I already said 3, I already wrote down 3 already, and x. You don't have to write down the 3 twice. What is the LCM? What's one thing, what's the smallest thing that goes into both 4, 3, and 12? I take that back. What's one thing that 4, 3, and x? 4, 3, and x, they all go into? They're all going to need, for x to go into it, it has to have x. So unfortunately or fortunately, they're all going to have x. Now, the first common multiple of 4 and 3 is 12. But the answer is 12x. I want one thing. That's why they're all the same. I want one thing that 4, 3, and x go into. And 4 goes into 12x, 3x times. 3 goes into 12x, 4x times. And x goes into 12x just 12 times. No remainders. So the LCM is 12x. And believe it or not, when we multiply everything by 12x. I want it to be clear as day that you need to have an x in your answer. How else is the x underneath that 7 going to get cleared off? Cancel out. Okay, so I come here and I denote that I'm multiplying each and every term by 12x. 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 4 goes into 12 3 times. So you have 3 times 3 is 9 times x. You have 9x minus 3 goes into 12 4 times. 2 times 4 is 8 times x, 8x. In the bottom, 3 goes into 12 4 times. You have 4 times 5 is 20 times x, 20x minus. The x's cancel. 7 times 12, I think, is 84. There's one way of writing the answer, but 9x, but you should finish. 9x minus 1x is 8x. And 4 goes into both of these. 4 times 5 is 20 times x is 20x minus 4 goes into the 8 2 times, and 4 goes into 4 1 time. 5x take away 21. Here's the answer. That's what that complex fraction equals. We are simplifying complex fractions. It's complex, I guess, because the numerator has denominators, the denominator has denominators, everything has denominators. Okay, suppose you have x squared over y squared, take away 4, and you choose to divide this by x over y minus 7. Y squared and y. Those are both the only denominators. And we talked about that earlier. The LCM of letters, well, they both have a common base of y, and you choose the highest power. When it was the GCD, or the GCF, then you pick the smallest factor, the smallest power. GCF, smallest factor, smallest power. LCM, largest power. And if you're confused for a moment, oh my, is it the largest or the smallest? Oh, I always forget this. I'm so bad at this. Fine, you forget it. But you should see as clear as day. If you put y down, fair enough. One y in the bottom kills off one of the two y's. One y on top kills off this y on top, one of the y's in the bottom. And you're like, oh, so I'm wrong because I'm not supposed to have any denominators left. I have y left. You have y on top and y squared on the bottom. You kill off one on top, and one of the two y's on the bottom go. So you have one left. That is why you multiply by y squared. So then the y squares cancel out completely. The y squares cancel out. And even over here, one y in the bottom, one y on top. There were two y's on top, now there's one. So the final answer is x squared minus 4y squared, maybe not the final answer, over y times x, or x times y, minus 7y. Now, it turns out that we can factor. The numerator is the difference of squares. The first term is x squared minus. If you square 2 times y, you get 4y squared. On the bottom, you can factor out a y, and you're left with what I didn't underline, namely x minus 7. So the answer will be for the numerator, you add the two things that were being squared, and then you subtract the two things being squared. And on the bottom, you get what we said, y times x minus 7. And you look to see if you can cancel top to bottom. When you realize you can't, you go back to each and every factor and you ask yourself, can I factor any more? And the answer is no. There is your best attempt for your answer. That's what you claim the answer is. Maybe you made a mistake. Fair enough. Nobody is perfect. But you tried to factor more. You tried to factor more, and you said you couldn't. At least you tried. That's important. Okay, let's try one more. And then I guess after that, I'll show you a new way of doing old problems. The new way would be the technique that we're learning with complex fractions. Okay, suppose you have this. You have 1 over x minus 5 plus 3 over x plus 5 over 4 minus 1 over x squared minus 25. Having said this for a while, because they seem to have always been factored, but you should try to factor the denominator. You can't factor x minus 5, you can't factor x plus 5, but you can certainly factor this one. And it's x plus 5 times x minus 5. I want the LCD. So, first you write down x minus 5. Then you write down x plus 5, because I didn't write it down yet. And then you go to write down x plus 5, and you say you already did. Same for x minus 5. So that is your LCD. You are going to multiply each and every term by x minus 5 times x plus 5. And since you do it to the top and the bottom, I didn't mention this. Since you're doing it to the top and the bottom, then you're really only multiplying by 1. You have 1 over x minus 5 plus 3 over x plus 5 over 4 minus 1 over x squared minus 25. So I'm going to denote for now what I'm going to multiply by. Now, just for the record, if I just said I'm multiplying the whole numerator by x minus 5 times x plus 5, that means I'm multiplying this by 1 over x minus 5 plus, and then I'm distributing it, I'm going to distribute it to the other part, the 3 over x plus 5. That is why I'm just doing it all at once. I'm distributing. I did that to the top. if I multiplied the bottom by x minus 5 times x plus 5, well then it would get multiplied by 4 and minus, and then it would get multiplied by the other piece. Okay, let's put the answer up here actually. So in the first multiplication, this cancels out, and you get x plus 5 times 1, which is x plus 5. X plus 5. Plus, because it really does say plus. The x plus 5 cancel, and you have 3x minus 15. Plus 3x take away 15. Now sometimes it's best to think of x minus 5 times x plus 5 as x squared minus 25. Like right here. When I multiply it by 4, it's the same as multiplying this by 4. And I'll get 4x squared minus 100. Minus. Now x squared minus 25 is this. That cancels out to 1. Times 1 is 1. So for the numerator, you have x plus 3x, which is 4x, and you have 5 plus negative 15, which is negative 10. In the bottom, you have 4x squared minus 100, and minus 1 more, minus 101. You can pull out a 2 from the top. And of course, unlike me, you have to do it correctly. You pull out a 2 from the top, and you get 2x minus 5 left over, 2x minus 5, and the bottom, you really can't do anything with. There's your answer. There's the answer. Alright, now, as promised a few moments ago, we're going to look at an old problem. It's not too old, it's from possibly even last section. And we're going to talk about solving it or simplifying it using the technique of dissection. If somebody asks you to divide 7 over 8 by 9 over 10, one way to do it is say, well, 7 over 8 times and flip over the 10 over 9. Keep the 7 over 8, there it is. Change the division I did and flip over this number. And if you can reduce, you can. 2 goes into both of these numbers 4 times and 5 times, and that's it. And we're reducing. 35 over 36. That's one way of doing it. Or you can say, oh, this is a complex fraction. Denominator, denominator. What's the first common multiple? And the answer is 40. Okay, I multiply everything by 40, top and bottom by 40. And why am I allowed to do that? Because 40 over 40 is 1. And 8 goes into 40. That's why we pick 40. 7 times 5 is 35. And 10 goes into 40 4 times. And 9 times 4 is 36. And we got the same answer. And I didn't have to reduce. I just, boom, there's the answer. It's not a bad way of dividing two fractions. 4 over 5 divided by 2. There's only one denominator, 5. I'd multiply the top by 5. I'd multiply the bottom by 5. And I would say the answer is 4 over 10, which you can reduce. Otherwise, you keep the top fraction, change the division to multiplication. The understood 2 over 1, you write as a half. And just like I did here, you say 2 goes into the bottom and 2 goes into the top. And you get the same answer. 2 times 1 is 2 over 5 times 1 is 5. You get the same answer. It's just another way of doing it. If you forget the keep, change, and flip rule, well then, you never should forget the multiplying by 1 rule. Kill off the denominators by multiplying all the denominators by the LCD. And remember, in this type of language, when I say denominator, I do not mean everything underneath that line. If you have A over B minus C over D over E over F plus AG, when I talk about denominators, I mean those. Okay, good luck with this.